This is going to be part 2 in the series of tutorials for the completing the app that I like to call Throw. And in part 1, we reached in the guide, we completed step number 10, which was to create that plane with its material, and now we're on number 11, which says that we need to create an empty game object. Obviously it's going to be a container, and its name is going to be ball and holder, and we're going to give that empty game object basically a reset transform, except x -1 and z 0.5. So let's do that. Empty game object, ball and holder, reset the transform, only x -1, which means, right now we're not going to see anything because it's empty, of course, and z 0.5. So it's half a meter in front of me and 1 meter to the left of me, because we're going to end up with 5 of them. Now we're building, of course, one of them. We're going to turn it into a prefab, and then we're going to have 5 instances of it. The next thing we're going to do is, as a child of ball and holder, we're going to create an empty game object, another one, and we're going to call it holder, but it's not going to stay empty for long. So let's do that. As a child, another empty one, which is going to be the holder, basically the bowl. And the holder reset. It's going to end up having some very specific transform, but for right now, I'm not going to worry about it because we're about to add to it a mesh. Into holder, drag the bowl mesh. Where do I find it? In the teacher's pack under models folder, but just the mesh, just the one that has the icon with a grid. So once I find this ball, I'm going to unfold it. It's got a lot of objects called ball, but only one of them is the actual mesh. I'm going to drag it to holder, and from that point on, holder will have a mesh. It'll have a shape. So where do I find it? Under project, teacher throw pack, models. Here's ball. I'm not going to drag ball into it. I'm going to unfold ball, find the one that's called ball but has like a grid icon, which is the actual mesh, and I'm going to assign that mesh to the holder. At that point, of course, I might be able to see it, but it has no material, which is why it's showing that magenta. So the next step is to give the holder the following parameters. So since they are pretty complicated, I'm going to move my screen so I can copy it while seeing it, because I'm not going to remember. Okay, so the holder now needs to be at 0.051 from the left, 1 meter in the air, y1, which brings it up a little bit, z0, the rotation, see how it's like rotated the wrong way, rotated 90 degrees, sorry, negative 90 degrees, very typical of things that were created in Blender, but it's huge. I need to make it much smaller, so its scale is going to be 0.13 on all axes, 0.13, and at this point I should see it a little more, let's say, in its regular scale. Also, if I'm looking at it from above, I should be able to see that here I am, and here's the first ball. When I rotate, holding option, I can see that there's a ball and it's about 1 meter in the air. It does not have a material yet. So we're going to create a new material. We're going to call it holder mat, and it's going to be just a flat color. We don't need an albedo for it, and we're going to assign it to the holder, to the ball, so it looks something like this. I'm just going to, I chose blue, but it's just, my choice. So in my materials folder, a material called, let's say, holder mat, and that material is going to be the regular, since it's URP, Universal Shader Pipeline Lit, this is like the equivalent of what we used to call standard in the built-in render pipe. And I'm not going to worry about base map or anything like that, just like, a light, nice blue. With, smoothness and so on, I can always worry about later, but I'm going to give it, remember, I can always drag it to the scene itself or to the object here. In any case, that's what it looks like. And when I look at it from above, that's what it looks like. Now, as a child of ball holder, so in other words, a sibling to holder, not a child of holder, but a child of its container, we're going to create a sphere. It's going to be called ball. .3D object, sphere, ball. Going back to holder for a second, just to show you something, by actually dragging that model, that mesh called ball, it also added a mesh collider to it, which we definitely need. Otherwise, the ball would just go right through it, like like air, like butter. And definitely, it has, it's using the mesh called ball also as its mesh collider. So in other words, it can actually hold things. Back to ball. Now, the ball, of course, is in the wrong place right now. So we are going to, we're going to give it the following transform, which is a scale of 0.3 on all axes, and reset transform, except Y a little hub above the holder, 1.23, which will mean it'll fall just a little bit when we start the game. So before I forget, 0.3 for its scale on X, Y, and Z, and 1.23, and that places it exactly inside, just a little above the ball. Obviously, the next thing to do is to create a material for it. Ball mat, and I believe the only thing I did for the ball mat, just to make it quick, is to choose for base map, what we used to call albedo, or in other words texture. Let's see which one. My material, ball mat, base map, ball billiard 03 diff, which is something that came with the teacher's pack. So base map, maybe a little easier to see it this way. Here it is, ball billiard, and this is what it's going to look like. And of course, I'm going to assign it to this. I prefer giving the ball not just a flat color, because then it's going to be easier to see it, like, rotating in the air. We can see the details on it. The same reason that we gave a texture to the floor. The next thing to do, so yeah, it looks something like this, is we're going to create a physics material for the ball, which we're going to call ball bounce. It could be in materials. We don't need a separate folder for physics materials, but create and physics material. Come on, here it is. Its name is going to be ball bounce. Its parameters are going to be very low friction on dynamic and static friction, in other words, very smooth, and let's say medium bounciness. Remember, bounciness can go from 0.1, from 0 to 1, so it's always 0 point something, so it's a little closer to 1. It's pretty bouncy. Friction combined minimum and bounce combined maximum. So 0.03 friction for both static and dynamic, 0.6 bounciness, friction combined minimum, and bounce combined maximum. Without turning this into a long lecture, the combined means what if it meets another object that also has a physics material? Will it combine their bounciness? Will it subtract their bounciness? In this case, the friction will be the minimum, like the smoother out of the two, and the bounciness will be the bigger out of the two. Next, We're going to go back to the ball and assign it the physics material. So, I mean, we created a physics material, but it doesn't have one. There's two ways to assign a physics material: either dragging it to the the object, or drag the physics material to its sphere or to whatever collider that it has. Then, the next thing to do is to assign a constant force to it. Let's do it first and then explain why we need a constant force on it. Remember, constant force is like, for shooting things, for like an engine inside. So why does the ball need an engine? Also, something that comes with constant force is a rigid body. They always go together. We're going to give them the following parameters. So I'm going to zoom out a little bit and move this like this, and this is the ball. Add component constant force, not constant force 2D, but just constant force. And that, of course, added a rigid body and a constant force. Now, for the rigid body, first of all, mass 2. So, in other words, I don't want a ball that's too light. I want it to have, basically like throwing a bowling ball, have some weight. Damping 0, angular damp, all this is a default. The one thing I will uncheck is use gravity. So are you saying that this ball is going to fly in the air with no gravity? No. Instead of gravity, we're going to give it, all these are, default. In the constant force, look at the only change we're making. Why? -1. This is artificial gravity, only it's weaker than regular gravity. This is why, if you looked at the demo, this is why this ball seems to be kind of like floating in the air as if it was like, in a very low gravity environment, by not giving it regular gravity, but instead a constant force with a y with a negative value. It's pushing it down, but we can control by how much. So in other words, if we increase this number, it'll fall down faster. If we decrease this number, it'll float, like more in a very low gravity. If we put 0, it'll be like 0 gravity. At this point, even if we don't add anything new, if we play, let's look at it from the side. If we play, we should see this ball kind of like settling down in the ball, unless we forgot something. And it does. See how it like fell down a little bit. It also means that I can simulate by, using the move tool in the scene, grabbing it, and it will fall down. It might fall into the ball, might fall out, and so on. You see how it's pretty smooth, so it continues rotating. Good. Don't forget ever to stop before you continue editing. Good. The next step is to add to the ball the component OVR grabbable. Now, let's not confuse that with OVR grabber. OVR grabber was already added to our hands. The hands are the ones doing the grabbing, but it needs to know that the ball is grabbable. So I'm going to actually copy that so I can search for it. How do I find the component OVR grabbable? I go to this ball and add component, and as I start typing OVR, I could also paste, but I can just type OVR. I can go alphabetically and find, here it is, grabbable. Not grabber, but grabbable. I don't need to change anything about this, just add it. You don't need to change any of the parameters. And also, we're going to create an add, just like we added a hand tag, we're going to add a ball tag, because we want to make sure that when the ball hits one of our blocks, it knows that it was hit by a ball and not by anything else. So we're going to add the tag ball. So ball, it's untagged, adds tag. We already have the tag called hand, but we're going to add one more called ball, lowercase, for no other reason than that's what the script is going to be looking for. And back to the ball and assign that. Safe. We did that, and that was step number 22. this point, if we have access to a quest, we should be able to build, and actually I should be able to see my hands, and using the side button, which is the grip, not the front button, which is the trigger, but the side buttons of both of them, if I touch one of those balls while I'm gripping, it will actually grab it, and then I can throw it. If you don't have your own, we'll build it in class. But the idea is that this is going to be used. It'll look like I'm grabbing with my hand, but actually I'll be pressing this grip button. It's time to create a prefab. If I'm sure that this ball has everything that a ball needs to have, and let's look at it, what should it have? It should have, of course, a mesh renderer for the material, a sphere collider that it came with that we didn't change anything about, a rigid body where we changed a few things, most importantly its mass and unchecked gravity, a constant force that pushes it down to the floor but rather lightly, and that script called OVR Grabbable, which tells the hand that it can grab it. So if it has all those things, we can go to our assets. I don't think we have folder like that, so we're going to create a folder called My Prefabs. And notice what we're dragging into it, not the ball, but the entire holder, like the whole unit, the ball and holder that has like a bowl and a ball. So it becomes a prefab. And then we're going to drag or duplicate, whatever, 4 instances of this prefab and start placing them side by side. So we're going to name them 1 through 5, because we're going to have this one plus 4 more. And then we're going to name them 1 through 5, and then we're going to give them all those X values, because they are just going to be side by side. So first of all, ball and holder becomes a prefab. Then I can drag 1, 2, 3, 4 of them. Right now they're all in kind of the same place, so ball and holder, same place. And I'm going to rename them. Ball and holder 1 instead of parentheses 1, we're going to call it 2. It's acting like in an array where the first item is 0, but it's more friendly if I call it, if it's 1 based. 3 and 4 and 5. They have some weird numbers to them because I dragged them in, but they need to have the same. If I hold all of them, the only thing that's going to be different about them is going to be their X. So I'm going to give all of them are going to have a Z of 0.5, and all the rest are zeros. So I actually selected all of them and 0.5. And the only thing different about them, you see how they're almost in the same place, is going to be their X. The first one, holder, is going to be -1. And they're going to be half a meter from each other. So this one is going to be -0.5, half a meter to the right. And this one is going to be 0 in the center. And this one is going to be 0.5, but positive. And this one is going to be 1. And now if I look at it from above, here I am, here are my hands, I can turn this off, and 5 of them in front of me. I can also switch to no perspective. So, and not forget to save and save. So, -1, -0.5, 0, 0.5, 1. For all 5 of them, the Y remains 0, not O, but 0, and the Z remains 0.5. Example, this is, for the 5th one, So, game window looks like this. Does it? Yes, it does. Now we will build the wall. So in this part of the tutorial, we will build the cube, and when we get to giving it a script, we'll switch to, I'll stop this tutorial and add another one. But let's do the first few steps. We're going to create one block for the wall because the wall is going to be instantiated through a script. So we're going to create a cube. All default parameters we set transform and call it, instead of cube, we're going to call it a block. Cube, and here it is. And of course reset transform. Now, if I'm looking at it from the side, and this is what it says, let me drag this up. This is what it says in the tutorial. Don't be alarmed from the fact that this cube is sunken into the floor. It's like half above and half below the floor. It's because its position is 0. But that's going to change once it becomes instantiated. So right now we're just building the prefab. Because it's in reset position, it would look half sunk into the ground, scene view. That's okay. In my materials folder, we're going to create a material for the block. We're going to call it block mat. We're going to assign it to the block. As base map, give it the picture called block, and as normal map, block normal. They should already be in the textures of the teacher's pack. So going back to materials, we're going to create a material called block mat. Give it to the block, so it has a default one, but for base map, for texture, we have something called block, and here it is. Just again to give it some, texture. If you want to, just to taste, you can also give it some kind of coloring and make it look golden, whatever. But that's what we're giving it. Feel free to add color or play with smoothness. We're going to add a rigid body to it because we want it to kind of like, act like a real object in, the physical world with the following parameters. So, cube selected. Yep, cube selected. We're going to call it block. We're going to add a rigid body to it with the following parameters. They're pretty similar to the defaults. Only changes are going to be that the mass is going to be 0.01. Now, unlike the ball that I want it to be pretty heavy, I want the block to be pretty light, so it's easy to knock them out. If the block was heavy, it would be basically like throwing a ball against the wall. The wall doesn't move. The blocks don't come out of the wall when you throw a ball at it, unless if the blocks were made like of styrofoam, then they would. So that's basically what I'm doing. So 0.01 for the mass, everything else stays the same. That's it. And then, since we already have a physics material called ball bounce, I'm giving the same bounciness to the block. So if I select it and I go to its box collider, it has no physics material, and I'm going to give it the ball bounce. So instead of giving it a separate physics material, they have the same bounciness. So when they hit each other, their bounciness will be combined because I set it to maximum. The next thing before we're done with it, I want this block to have an audio source, and it's going to have an audio resource called Impact 1. We're going to uncheck Play on Awake because, of course, the next script we're going to write is going to trigger the sound only when the ball hits the block. But we need to prepare it to have a sound. I'm going to add audio source. We're going to uncheck Play on Awake, and for audio resource, it used to be called clip in earlier versions, we're going to select Impact 1. Not this, but this. Nice and deep. The other thing that I'm going to do right before we're done with this, I'm going to set the spatial blend, which is like the slider between 2D and 3D, to 0.7. In other words, what I want is for the sound to seem to come, here it is, spatial blend, from very close to where the impact happened in the 3D world. Save and save. The next few steps are already taking us into scripting. To the ball, we're going to add a script, and we're going to move, the script into my scripts folder and replace it with this code. But this is going to be on the next tutorial. So what I very much recommend is before you look at the next video tutorial, to actually do steps number 34 and 35. And in the next tutorial, I will discuss, it's a very simple script, I'll discuss how it works.